for another video. And you can see behind me an 8-wheel drive Argo. Attached to that is a Watersnake outboard, and that's what we're here to have a chat about today. Well, I'm still recovering from coming close to chopping a finger off in this thing, and not in the way you might expect. People would think that I got my finger collided with this bit. It didn't happen. I got my fingers stuck in here. It happened about a minute and a half into the water. I'd shut the engine down on this. I was dropping this in the water and my apprentice shifted at the wrong moment. Now there's two factors at play here. One is this little thing and one is this little gap. I'm hoping this video will make its way to Watersnake or a Watersnake rep so that they can pass on this little idea. Mostly because I don't want anybody else to go through the same thing I did, and in practice I found Watersnake are very difficult to contact. Now, the primary thing that led to me having my fingers in this position anyway is this little lever here. The way it pushes, when you try and push this down, it's meant to disengage this lock here. But in the initial position, when it's locked in and there's a bit of resistance here, even with both thumbs on this, you risk nearly breaking this off because it's trying to push this sideways. It isn't until it's partially pushed down that that mechanical advantage works well. This piece needs to be redesigned. That leads to an awkward position where I have one hand here and my thumb on top of that to push it down, so I can use this fit for mechanical leverage. That is not ideal, because once this thing starts to move and lift up, you can see how this gap cantilevers and closes, and then once you reach this position here, that latch locks, meaning your fingers are stuck. The only way to get your fingers out of that is to put additional downforce on that piece. So my proposed solution is to make a little square piece of timber or plastic that I can stick over this hole. That'll prevent my fingers from going in here, or at least provide a reminder, and this little radius here should push my fingers out of the way should I find myself doing something stupid again. I am going to cut this piece off or knock that pin out, and I'm probably going to put a bigger piece just simply on the top of this, a big knob that I can get both thumbs on, so it doesn't need all this mechanical stupidity here. Just a big knob on the top of that is all we need. I can probably 3D print something, and I have a laser cutter. I'll find some suitable material and some epoxy. I'm pretty sure that an injection molded piece of plastic could go in there, and then Watersnake won't have to go to the expense of retooling all their molds for this. They can simply make a little snap-in, clip-in plastic piece that drops in that hole from both sides. I think it's a simple, probably very cheap fix that might prevent other people from nearly losing their fingers. And I have to say that if there was any more haste involved in this, the leverage of this at full length could easily have severed my finger. So Watersnake, here's my fix, and I hope you guys adopt something similar. Now it's worth noting I'm making extensive use of voice controls in the Argo today, because there is some quite significant damage under this band-aid, and I have required a tetanus shot and a trip to the hospital and antibiotics. Anyway, we want to measure this gap. Now, it's worth noting I don't intend to patent this. I would just really like Watersnake to implement this idea. So we are looking at a bit more than 75 mil. We're looking at about 77 mil. Although my laser cutter knocks a half a mil off. So we are going to go 77 millimeters across the top. How deep do we need to go? Deep enough that we can avoid getting our fingers stuck in here. 50 mil looks like it would fit nicely, but we need to operate off the shortest depth in here. So we are looking at 45 on one side, and we'll say 50 mil on the other, and we'll taper that across. Say 50 mil to the other side, and we'll go 50 on that side, and we'll take a zip across. So we end up with a crude hand-drawn diagram like that. I need two pieces, roughly those dimensions. I can draw that up in AutoCAD in a few seconds. So let's go do that. now in my workshop, and as you will have seen, it took me under a minute to draw up a solution to that in AutoCAD, and I think about 1:30, about half of that time I think I was spent just trying to sort out where to save it. So I had to clean out some junk out of my laser. This has been in here since I did the slow vehicle signs, and we need to find some suitable material, which is probably going to be the bigger issue. I have some metallized acrylic. I've got some two-tone stuff in here. I could probably almost cut a piece out of this that says warning, keep fingers out, but anyway, I probably have some 3mm clear acrylic over in here. What have we got? 3mm acrylic. This will be suitably water resistant, and should allow me to see what's going on in there and avoid any sort of interrupting the aesthetics of the outboard, although it's a bit dinted up at the moment anyway. It has had a bit of a hard life, I will admit that. So 2 pieces of this clear acrylic I think should do. So let's get everything fired up. And then we'll get into the computer here in a minute and we'll load the job up. Alright, I've got this loaded up, ready to go, and I thought I'd stick my name on it. At least just so people know that this isn't something that Watersnake did. I really wish it should be something that Watersnake should do. I'm going to repeat that a few times. Now if I could do this with a couple of buggered fingers in 1.5 minutes, what can Watersnake do in a mass production perspective? Anyway, let's cue this up for plotting. We are going to plot it same way we did the previous one, and we are going to offset probably 4mm from the edges. We're going to do that, and we're going to send it over to laser cut. And I could pair up 2 at once, but I'll just move the sheet. Alright, let's go check how this cuts. Alright, we're over on the machine, and we are going to just change the settings slightly. We're going to go over to raster setting, and we're going to bump it right up to about 38 or 40%, somewhere around about there. You can see what we're doing here. We're almost there. I find 38% for this acrylic's good, and I know for this acrylic we need to slow it down just a tiny bit. So we want to just go just a bit. That should cut through nicely. Okay. Now we need to bring our head over the material here. I'm going to autofocus with my finger out of the way. It's a bit hard to do this left-handed these days because my finger bloody hurts. Thank you, Watersnake. Right. Now let's get this thing cut. Okay, now because I've put text on this, I'm going to make a left and a right-handed one. And this is made out of scrap, so there's a bit of glue residue on here. I'll give that a bit of a clean up. But that's one side. I've mirrored it and resent the job, so I cut ourselves a left-handy. But that whole job didn't take very long at all, even including the laser cutting. It only took a couple of minutes. So yeah, anyway, let's make the next one. Alright, next side, away we go. I'm going to sit here and whiz away. Let's go clean this up while that one cuts. So, grand total for the cut job with the fancy text is 3 minutes. I would be probably about 2 minutes or 2.5 minutes shorter than that without the text. So for 30 seconds a piece on a laser cutter, you could fix this. Come on, Watersnake. Alright, here's our left and right jobbies. We've got some araldite to stick on here. This is 5-minute epoxy. So I'm going to use to glue it on. Take a little bit of sandpaper out there to clean it up. And I'll give these a bit of a wash in some warm soapy water. and ignore how messy my desk is. I haven't been out here for a while. Anyway, let's go stick these things on. Alright, well, we're back outside. I'm going to peel a bit of sandpaper off. I'm going to give all this a bit of a clean and a roughen up, just to make sure this epoxy bonds better. So I'm thinking a rag and some alcohol might be a better job, because it's difficult to get into here. And as usual, every time I want to do something like this, the wind picks up and has blown my sandpaper away. Anyway, we'll be back after I've cleaned this. Now it's time for the epoxy, and I've got this special mixing nozzle here. This is 2-part 5-minute epoxy. Now I should probably check that this fits. It does, and it'll probably drop right through. Yep. So I'm going to need some tape to hold that on. Let me grab some masking tape. Alright, so thanks to this very issue, I am working mostly one-handed today. So I have to prepare my tape ahead of time. So we're going to stick all this on. I'm going to flip this over upside down. I'm going to apply epoxy to the top edges. And that looks like the top edges there. Let's see. Oh, the epoxy is nice and warm, which is good for bonding and accelerated setting. Well, went off the top here. This is not going to be my prettiest glue job, thanks part to the one-handedness. And we're going to tape this guy in here pronto. Stick this one in, tape her all up, and we'll do the same on the other side. Alright, our two guards are currently setting. We'll be back in about 10 minutes, even though it's 5-minute set epoxy. We'll be back in about 10. We'll peel the masking tape off and see if these function as desired. I'll probably remove this stupid little thing, and I'll see if I've got a knob, although that might be for another episode. Consequently, if you're interested in the series of events that led to this, I'm going to put a link in the description to my previous video that actually details somewhat of what happened. If nothing else, this cost me a weekend of trolling anyway. And not the internet trolling, the trolling motor trolling. Anyway, as you probably guessed from the tone of this video, I'm quite frustrated with this situation. So I think they've probably just opened that up just to save themselves a bit of metal in the casting process, and make it a little bit cheaper, whereas I would gladly pay the extra money for this not to have happened. Anyway, let's move on. Right, so it's been more like 15-20 minutes. So let's peel this off and see if it's stuck in here. It looks like it did. Alright, peel this one off here. Yeah, this one ran a little bit, but it's quite sturdy in there, and there's no way I can get my fingers stuck in there. Let's actually get up and replicate where I had my hand. Yep, that's not possible anymore. And I'm hoping that's a suitable angle that when I fold this up, it won't collide. But let's test that. It's going to be a touch tricky with a knackered finger, but let's see if we can pull this bit up. Undo our straps. Right, slide this forward. Now, when there's any kind of weight on here, that won't go down. So we'll do this. Right. Yep, that's going to go completely down. Alright, so typical of everything I do, the tolerance is a bit tight. There's a bit of glue residue that has sat in the bottom there. Makes it a little bit firm to lock into place, but I can still get the wedge out. So I'm going to leave it at this, and then I'm going to go and sort out the rest of it later on. I'll sort out a knob and I'll remove this at a later date. Primarily I wanted to get that gap sorted out. So let's get this folded up, stowed away, and I'll go back to my desk and finish this video. Okay, so now we're back in air-conditioned comfort. I need to have my bit of a rant about this video. Now, firstly, there will be some of you, this is the internet after all, who will get in here and say it was my own stupid fault for putting my fingers there. and that the manual probably says don't do that. Well, I went back to the manual and it doesn't strictly say not to do that. It does say to be careful. In any case, yes, part of the fault lies with me. But that doesn't mean that this design can't be improved. Now, there's stupid things you see on the back of things like toasters, do not use as toilet seat, and stuff like that that you have no idea how those things ended up on the warning labels. This one's a pretty plausible one if you ask me. And there are some faults in the design that are very simple and very cheap to fix. And I think manufacturing wise it would be cheaper to put a knob on that little button rather than that stupid lever that doesn't always work, and it hasn't from new. And I think it would be very easy for them to have some sort of plastic part, or even maybe change the molding, but a plastic part for sure would have to be cheap. Even a piece of sheet metal that they stick on with some adhesive, bit like stickers, and they could mass punch that out of 1/2 mil sheet metal and it would even fix the problem. There are so many ways you could achieve a flat piece of metal to fit that hole. Anyway, they need to fix this. If you guys feel so inclined, I'd encourage you to contact Watersnake and suggest this modification. I don't care if you take credit for it, it just needs to get fixed. Anyway, we'll see you in the next one. That's my rant over, and yes, I've hopefully fixed this one at least.